Hello, there are lots of different types of components in physics. What I'm going to look at is 4 resistance behaviours with you in this video. These are skills that you will be able to transfer if you do go on to do anything to do with electronics. This is directly related to what is on the AQA specification. Right, okay. Now, what I've done is I've pre-drawn out 4 diagrams. What you will notice is similarities in most of the diagrams, and there are a few differences as well. Okay, so let's say you've been asked to describe an experiment for investigating how an ohmic resistor works. First thing that you'll need to draw is a variable resistor that's there for changing the current in the circuit, a power supply that's there for supplying power to the circuit, and an ammeter that's there for measuring the currents. Okay, if you're asked to investigate an ohmic resistor, then what you would do is you would place your ohmic resistor is represented by a rectangle at the bottom, and you would need a voltmeter in parallel across that to investigate that further. In terms of the technique for investigating the resistance of this, what you would need to do is you would need to take a current reading, and that's from the ammeter. Take a voltage reading, and that's from the voltmeter. You'd need to vary the current using the variable resistor. So that's manipulating the value for the current, and then you would need to state that to calculate the resistance equals voltage divided by current. Remember, you will get credit if you draw a diagram, and you're heading for 6 marks in that situation there. If you are asked to draw the current voltage diagram for the ohmic resistor, it's directly proportional, and it's the same forwards and backwards. So if you turn your resistor around, you will get the same result. Right, okay. Now if you're asked to do the same for a bulb, exactly the same circuit, except we draw a bulb in its place this time. In terms of this, it's exactly the same method. So there's no different method to learn. And in terms of what this diagram looks like, people remember it as being that S shape. So it starts off straight and starts to curve upwards. And there it's doing the same in the opposite direction, where you've got current and you've got voltage. And if you turn it the other direction, then you get exactly the same result. Okay. Now, the reason why we have got a resistance increase, so the resistance increases, and therefore the current does not increase at the same rate, okay, is because the bulb gets hot, which means the ions inside the bulb vibrate more, and that's because they've got more kinetic energy because the ions are heated up. So therefore there are more frequent collisions, and as a result the resistance increases. So if you're asked to explain that phenomena, that's what you would get for a bulb. If you're then asked to investigate a diode, a little bit of an extra thing for you to do here. So what we would do is we would draw the diode symbol, which is a triangle with a line next to it. you'd have to draw a protective resistor next to that, and that's a rectangle. And there we go. Okay, so there's your diode and there's your voltmeter across. Same method, exactly the same method again, except this time, and I'll use the same pen for consistency, what happens is forwards and backwards, a diode only allows current to flow one way due to its structure. So a voltage behaves normally at about 0.6 volts for a semiconductor diode that's made out of silicon. You don't need to know that, but that does account for that gap. And in the other direction, it's completely flat. Okay, so in the other direction, it's completely flat. So same practical. The only thing that you would need to remember is add a protective resistor. And the only reason that's there is to prevent voltage breakdown of the diode. I haven't seen that come up in a question, however, that is technically correct what you do. There is no need to know about any different configurations for that. Finally, you could be asked to investigate how the length of a wire changes the resistance. Now, what you would need to remember is you would need a voltmeter, but this time you would need crocodile clips, and you would need a ruler, so you could vary the length. You'll notice there's no variable resistor here, so you use the ruler to measure length, and the thing you are changing this time is you are changing the length of wire in contact with that voltmeter, and you do that using the crocodile clips. Because in terms of the electrons, if it's longer, it will encounter more metal ions. Length increases the resistance, and that is a directly proportional relationship. So as the length increases, the resistance increases. And those are the 4 experiments that you need to know about, and they come up on the required practical part of the specification. I'll leave you to bask in the 4 practicals there. I hope you're all well. Thank you very much.